Hi folks. So in this part of the tutorial, we're going to look at some real world applications of vectors. In this case, we'll be looking at the displacement vector going from one place in San Francisco to another place in San Francisco. So for our first trip, let's start at the Union Street shops and we'll go to Civic Center. The direct way to get there would be to go from, say, Green and Laguna Street, and we're going to go straight down to Fulton and Van Ness. All right, so we have a vector here that is our displacement. It has a specific distance and it has a specific direction. It goes from where we were to where we want to be. Now, to get there along this particular path, we would have to go through a large number of buildings and get a large number of people upset at us. So instead, let's take the streets. All right, the streets in this area of San Francisco are more or less north, south, east, west. So to get from Laguna and Green, well, let's head east along Green. Okay, let's head east along Green Street and then south along Van Ness. Okay, we've taken the streets. We've started in the same spot. We've ended in the same spot. Okay, so these two vectors, which are perpendicular to each other, the sum of these two, so we drive 4 blocks east on Green, and then, oh goodness, it's about 12 or 14, however many of these mini blocks are, and then several blocks south on Van Ness. Or we could do it this way. We could start on Broadway and Pacific. We could start on Green and Laguna, go down Laguna Street all the way to Fulton Street. We could turn on Fulton Street and go over to the same location. What that tells us, for one thing, is that this vector, the pink vector, which goes 4 blocks eastward along Green Street, is the same vector as this purple one that goes 4 blocks east on Fulton Street. They both have the same magnitude, 4 blocks, and they both have the same direction, eastward. In the same way, our pink vector going down Van Ness, south on Van Ness, has the same magnitude and the same direction as our purple vector going down Laguna Street. Now we could take other combinations of streets if we want to. For instance, we could just as easily go 3 blocks over and a few blocks down. We can go left for a block for some reason, then go out down Octavia. Oh, we have to turn on Geary, so we'll have to turn on Geary all the way over to Franklin, and then we can take Franklin down to Fulton Street and then Fulton Street over here. So once again, we've started in the same spot and we've ended in the same spot. So the sum of all these vectors must equal our original, well, now it's almost covered, our orange vector. I have one too many little red vectors here. There we go. Oops. All right. Okay, there we go. Let me undo that erase. Okay, good. Now we've got the purple one, and I was trying to erase that little red one. Okay, that little red one is good. All right, so the vector that goes directly from the shopping center to the civic center, okay, the sum of eastward vectors and southward vectors is the same no matter which possible path you take to get from one to the other. So if we look at our red path, we've gone 2 blocks east, a few blocks south, 1 block west, a few more blocks south, and another block and 2 blocks west, and then south, and then another block to the east. Or this one is east rather. But what we've done in the red path is we've gone 4 blocks east and we've got 12 blocks south. We've gone the same blocks, we've gone the same distance as if we had taken the pink or purple route. Let's look at another one. Okay, let's say instead that we're trying to get from the Powell Street BART, and we want to go, and we want to go from the Powell Street BART, and we want to go to AT&T Park, to the parking lot down here on King Street and Stanford. Okay, so what other ways can we get there? Well, let's look. Let's see, we could go along Market Street, and then we could turn right on 2nd Street, and that should take us, and that turns into Stanford. So that should take us right there. Okay, so we've added, okay, this northeast vector plus this southeast vector to get a slightly southeast vector. Okay, so we've added two components that are perpendicular to each other. Right, we have two vectors that are perpendicular to each other that we add together to get another vector. So these are the components of this vector. And similarly to our previous example, we can start at Powell Street and we can go down here to, say, Townsend. This actually should reach King Street. I'm going to pretend I'm going straight down the road to King Street. Okay, and then turn left on King Street and go up to AT&T Park. So that means since our pink vector and our purple vector have the same length and are going in the same direction, these two are the same vector. Similarly, as we're going up Market Street or going up King Street, we're going the same distance in the same direction. So once again, these two are the same vector. And if we want to make a much more complicated route, we could take Harrison. Oh, I missed the turn on Harrison. Let's go this way. Okay, let's turn right here. All right, and I want to go back down to King Street. Oh, we can't get down to King Street that way, so let's go this way, and then we'll go over here. Okay, I can finally get to King Street. I can finally turn on King Street, and then King Street will take me down here. This ridiculously long path, if you add all these vectors, red vectors up together, you get the orange vector, which means if you add all the, well, parallel pink and perpendicular pink components of our red path altogether, once again, you get our orange path, a direct line from Powell Street to AT&T Park.